Number 10. What is the square root of 144 plus the square root of 100? Now, 1 square really means 1 times 1, 1. 2 squared, 2 times 2 would give us 4. 3 squared would be 3 times 3, giving us 9. 4 squared, 4 times 4, giving us 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 10 times 10, 100. 11 squared, 11 by 11, 121. And 12 squared would give us 144. Now, when they say square root, they're asking you to identify the original number that was squared. So 3 squared would be 3 times 3, giving us 9. So the square root of 9 would be 3. So using this information now, let's answer the question. The square root of 144, one of the original numbers that was multiplied, would have been what? 12. So 12 times 12 would have given us 144. What that 12 is the original number. Plus, what's the square root of 100? It would be 10. So 12 plus 10 would give us what? 22. So our answer would be what? D, 22. In class recently, we looked at how we would find the square root of some numbers using a different process. Let's look at finding the square of 64, for example. So we have 64. 2 can go into 64, 32 times. 2, again, this is an even number, so I can use 2. 2 could go into 32, 16 times. Again, an even number. 2 can go into 16, 8 times. Okay, 2 can go into 8, again, an even number. Remember our divisibility rules. 2 can go into the 8 4 times. 2 can go into 4 2 times. And 2 can go into 2 1 time. Now let's list all of these. So how many of them we have? 1, 2, 3, 4, 5, 6. So 2 times 2 times 2 times 2 times 2, 2, 3, 4, 5. One more. Good. Now we're going to pair them off. One set, 2, 3. Take 1 from each pair. And we multiply that, and we'll get what? We'll get the square root. So 2 times 2 would give us 4, and 4 times 2 would give us 8. So the square root of 64 would be 8. This works for perfect squares. All right, so that's one way of getting to the square of certain numbers. But going back to number 10, our answer would be 22.